Hey, what's going on, guys? Against here. Today, I'd like to kind of like officially announce that I've just started working on a Stockfish fork dedicated to Chinese chess Xiangqi. So this has been requested before, and there already exists some implementations, some Stockfish forks that are actually able to play Chinese chess, like Fairy Stockfish or Chameleon. And by the way, in the previous video I made, I was running perf test for starting position at depth 5, and with the comparison of the speed of actually the amount of time taken to take that test. And quite surprisingly, it turned out that my didactic CNC engine Wukun, which is written in JavaScript, is about equal in speed of the perf at the depth 5 to Fairy Stockfish. Believe it or not, it's slightly slower. But what is even more surprising, that Chameleon, which is the CNC Stockfish fork derived from Stockfish 7, is actually even a bit slower than the Wukun itself. So the C++ engine is kind of like slower compared to the JavaScript engine. Believe it or not, that's really hard to believe in. But so if you're interested, you just can watch the previous video within this playlist. So if you don't know where to have this playlist, you just go to chess programming playlists and CNC Stockfish. That would be the playlist called CNC Stockfish, and you just have a look at the previous video. This would be video number 2 by the time when you would be watching this. So there I just compare the perf results, and also providing the explanation by the author of Fairy Stockfish Fabian feature, that actually who explains the reasons behind this significant slowdowns. So I don't know, probably people would hate me for considering array-based approach, but and again, like just to give you an idea, that I'm going for this array-based approach not because I'm not familiar with the bitboard. So I've created once I've created International Western Chess Engine called BBC, which is covered in 95 video series here on Chess Programming channel, and it is actually it does actually use bitboards and magic bitboards in particular. So it's really lots of tutorials here. It's has quite pretty solid rating with this Stockfish's efficiently updatable neural network. Without this, it's just only 2100. It's nothing much, but actually NNU is really strong stuff. But it's not really the case that I wanted to tell you. So the core idea I'm about to give a try to is to use this array-based board representation and make use of Stockfish's search. So actually what I need from Stockfish is the search, and that's it, literally. Well, UCI protocol as well, which I would probably convert to UCCI to support like Universal Chinese Chess Engine. But I would probably even leave it as is. I'm not sure really at the moment. It's hard to say. But anyway, this project is the very first C++ project in my life. So I've never been coding in C++. I'm very familiar with the C and really done a lot in C in chess programming. I mean, but C++ is really new stuff to me. It's kind of like a monster to to deal with, but it's really fun, I need to say. So in this video, I just want to show you the way, probably it's a very bad way of doing things, I don't know, but for code monkeying like me, it's probably the only acceptable way of proceeding, basically. So I just want to show you what I did so far with the source code, and what did I learn from the Stockfish code base, how I'm getting familiar with the Stockfish's code base, and what are the next steps, well, this in theory, that I'm gonna be doing. So without further ado, let's actually dive into the code. So here is my local copy. See, like this object files, which means that I'm already building the project. So I don't even know where to Well, I'll probably show you how in particular did I. Just to mention the entry points, if we go to search CPP in the Stockfish and we search for perfed, then here we have a very basic routine, actually relying on the core features of the move generator itself. So we have this position do move and position undo move, which is really the core. So we have a position object, well, which is probably the instance of the position class, I believe, and all this stuff actually kind of like happens right over in there. And I didn't even, well, and on the other hand, so just in order to try to, I don't know, change the code and see how it works. So another thing to consider within the UCI, we have, well, first of all, perfed itself is available as the command within the go command. So like we can say not only go move time, go fix depth, but also we can say go perfed. So this is how it's done in original Stockfish. And another thing, which kind of like a shortcut to, I don't know, nobody debugs like I do, but I don't really want to touch Stockfish's code as much as I can, basically. And here is a command, so if you just type D, it prints the position. And if we just go to, so it's kind of like, I don't know, I don't even know how to properly call this. Well, in Python, let's say, if you want to print if you want to print the object, there is a way to return text when you just trying to print an object instance. So instead of printing the memory address of that instance, it's actually write something to the output stream. So it seems like the same stuff is available in C++ as well. So if we just go to position CPP, well, actually, also I want to open two files. So I'm working with the types. I'm working with, which is the general global kind of like types and variables. And another thing to consider is, hold on a sec. So position, where is the position? Position CPP and position H. So position H is the declaration of this global position object that is also responsible for making and unmaking moves, for keeping track of the board position. So here I'm going to be adding my array-based board. I'm not going to be touching all of this stuff that is already there. Maybe one day when I be smarter than I am now, just get rid of that. But at the moment, if you're just trying to take away a single line of code, it just gives a tons of errors to straight ahead. So I'm not really ready to deal with that because I have no idea how it works entirely, like the entire picture of how it works. I don't yet see this. So at the moment, what I'm trying to do, I just want this perfed running, actually making and unmaking moves for relying on my Chinese chessboard representation. So just avoiding using the standard Stockfish's functionality and actually trying only go in for this kind of like CNC related do move and undo move. So those would be altered, obviously. So I'm not deleting Stockfish's code. I'm just trying to embed code that regards to CNC along the way, and then I'm going to alter the functions. So in order to actually interact with the board array, not with the bit boards that I'm going to be adding. So the board array itself would live here. I don't know, probably I will create some different type than integer for it. Maybe not. I don't know. It's really a little bit of an unclear to me at the moment. And well, definitely in position CPP there would be like some logic to probe that board. But here is the function I've been mentioning. So as they say, so returns ASCII representation of the position. So I've just commented out the code that is there at the moment, and trying my own stuff, just trying to reference the variables, trying to reference the variables that I'm creating here within the types. So just to give you a very quick demonstration, so if I just go and run this, okay, open terminal. Okay, so nothing to commit. So D for debug, and here is my stuff. So I just print the board and print the piece type for black advisor, if for white advisor, if I'm not mistaken. Piece type. Yeah, for advisor type. Nothing much really. So again, like before this, it was actually so. Eventually, a board position would be printed here. That's what I want to come up with eventually. But at the moment, well, so just get rid of this stuff and restore the original code that was there actually. Just to give you an idea regarding the entry point of where am I trying to step into the Stockfish's code base. Okay. It takes a bit of a time to link all this existing compiled files. So let's wait for a while. And yeah, and by the time it's happening, so here by the time it's compiling, so I've created a section for CNC types within the types.h, which lists literally all the types that are used by the Stockfish. So really lots of things here, and in order to avoid any possible duplication for piece codes or something, or colors, I'm just doing the following stuff. So I'm using this XQ prefix for all of the to all the constants basically. So here is just code begins part of the code. So CNC related stuff begins here. So I'm just defining the starting FEN to have a shortcut as a global definition here to this initial position. Enumerating colors, piece types, piece codes, piece encoding, piece types, some mappings for speed up the move generator, which really makes sense. Square encoding, and now I'm trying to debug this kind of like ASCII representation of the codes. So Stockfish does this in a more fancy way somehow, but I really tried to keep my code as modular as possible and trying not touching Stockfish as much as I can basically. So that's kind of like the goal. Maybe further on when I'll get a little bit more okay with the infrastructure, with the environment, maybe I would have changed that. I'm not sure. So by default, if you print D in the UCI mode within the Stockfish, it just prints the board and generates the FEN and gives the hash key. So these are the most essential things to consider basically. And this FEN generation is really cool because it actually allows to see the actual current site to move, castling rights, etc. Obviously, we don't really need the castling rights for CNC, but just to give you an idea, if say like I go for position, start, pause, moves, and E2, E4, and then print the board again. Okay, hold on a sec. Position, start, pause, moves, E2, E4. Okay, so now see like we just moved the pawn. You see like site has changed. Well, I'm not really sure why in peasant square wasn't set to E3, which it should be actually, but doesn't really matter that much. So probably, yeah, probably, but it doesn't matter really. So this is how it goes, and one of the first goals for me to consider is just to create an array-based board representation forked from my Wacom CNC. here within the Stockfish and try to print the board, and that's it. Very simple. And then just providing the move generator, and eventually I just need to fill up the move list, which is available there. So, and then going for a perfed. So it's quite pretty simple, seemingly. So again, like, so just to give you an idea, so what I really, you know, like the very first project I really did from scratch on my own without looking to someone else's code is this Wukong CNC engine, the Chinese chess engine that I've been covering in really tons of videos here on Chess Programming channel. So here is the code. So it's really easy to go from JavaScript to C. Okay, so this is how it goes basically. So I just use board array and this state variables. I don't even need this gameplay search play because all the search is handled by the Stockfish itself, as well as the move stack, I believe. Maybe only keeping track of the king square might be on the cards. Altering the logic for hashing is also on the cards. But again, like, so this is what we have. So, and it's not really that many code here, not really that much of code here. So the move generator itself, so yeah, probably can say that it starts from here. So code for E-square attack, one of the essential functions. So it's not really that big, right? And also go for a move generator. Here it is. And this is it, literally. This is it. And then just make move. It's quite pretty simple, way more simple compared to how it's done in international Western chess, because no castling, no peasant captures. Well, null move is also might be on the cards, but again, like, yeah, I think, well, I'll need to definitely, I would need to alter this, but I just want to say that the entire source code, this is it actually. So the search probably takes, in Oakland, search takes the most, like maybe not the most code, but probably the part of the source code is the search routine here. Okay, so also the API that I have. Well, again, so just to give you an idea, the Wukong.js is more like a library for move validation, and I was using this in my in the GUI that I've developed to play games between Chinese chess engines. So with that GUI, I managed actually to play game against Fairy Stockfish and Chameleon engines, which was really fun, and also games between Wukong and Fairy Stockfish, Wukong and Chameleon. So if you go to the playlists and chess engine games playlist, you can see some videos there. Okay, guys, so that's the way how I go basically. Yeah, you can wish me good luck with this project. I don't know, so it's really time consuming apparently, so it's nothing really much to say more about this, but probably, yeah, the very last thing that I want to show, that I want to demonstrate. So if I go to the MoGen, so here down below, all this stuff is coming to, so if you just go to perf again, like, so to generate all the moves, we just iterate over the move list. So this move list has to be populated, and this is done within the move generator, and I'm not sure yet how exactly that happens, but eventually we need to return this move list. I'm not sure whether this move list is exactly the same as this one. I don't even know whether this is the type or the variable name, or probably it should be a variable name, but I'm really confused by these templates, to be honest, guys. You know, like, yeah, it's really overwhelming. So this templates is something I don't really like, but doesn't matter really. So eventually I would need to return the move list from my own move generator. So I don't care about what is in here in Stockfish. So just write my own code, return the moves here in the move list, then try to go for a search, then try to go for a perf, then going for debugging this the incremental updates of the hash keys. Well, this all is the part of the perf still, so it's the part of the mode generator basically. So like not only making moves and making sure that the number of traverse nodes is fine, but also you need to make sure that hash keys are getting updated properly. I'm not going to be using piece lists even here at the moment. Maybe I would add them later on, not sure, but at the moment, just for simplicity, I just really want this proof of concept mode generator generating moves to play Chinese chess connected with search of Stockfish, and just to see how likely it would be going. So it's really tempting to see basically. So I think that in theory that should already be enough to beat both Fairy, Stockfish, and Chameleon in Chinese chess, even with a rudimentary evaluation. I believe that might be on the cards, because the engine would be really faster. But before that, we'll definitely compare the perf test results as well. If I leave, if I would survive this development process, obviously. Okay guys, so this is it from my side. Thanks for watching. Until the next time, and take care.